All right, we're going to talk about end behavior of polynomials. And the reason why is because I would like you to be able to graph polynomials, and I'd like you to be able to look at the graph of polynomials and have a sense of what the function might look like, the equation for the function. So in order to understand end behavior of polynomials, we have to understand a couple of things. One of them is the degree, and the other thing is the leading coefficient. The degree is the highest power. Sorry about that. I didn't want you to wait while I was writing all this out. The degree is the highest power of the variable in the polynomial, and the leading coefficient is the number in front of the term. The term with the highest power variable. So you'll notice that here in this table it lists the number of terms. So in this case we have 1, 2, 3, 4 terms, and in this case over here we have 1, 2, 3 terms. Terms are things that are added together. You need to know that definition. And in this case, even when we have subtraction, we think of that like adding, because minus 2 is really like plus a negative 2. So really this is just 3 things added together. So this, you don't have to write down the number of terms. I just wanted you to look at it and compare it to these guys so that you had a strong sense of what terms were and how to identify them. You also don't need to write down constant, linear, quadratic. I could care less about that. What you do need to know is the degree, the number, and where it comes from. Notice here we have the number 3, and it's because the highest power of any of these variables is 3. The degree is the highest power of the variable. Okay, and here we have 5, and there you go. Now, the only thing I don't like about my examples here is that the degree is the highest power of the variable. So I want to point something out. If we have something like this, the degree is not necessary. Well, let me put one more number in here just so I can be happy. The degree is not necessarily this number. Let me go ahead and circle it for you. The degree is not necessarily this number. In fact, it certainly does not have to be that number. The degree is the highest power of the variable in the polynomial. So this guy would be the degree here. It's a 9th degree polynomial if it looked like this. Now technically we should reorder this guy, and if we did, then this guy would be at the very beginning. Also, the leading coefficient for this guy right here is not 6. It's -3. That's going to be the leading coefficient. That's the LC. And this guy up here is the degree. Okay, so and there's something else that's kind of interesting too, is that we call the very first term, if we put them all in the proper order, we call the first term the leading term. So this guy's the leading term, leading term, leading term, and certainly this guy, if we put things in the proper order, would be the leading term. Okay. I just had to get that stuff off my chest. Thank you for listening. All right, now let's get back to what else we're going to do with this stuff. We needed to know about the degree and the leading coefficient because we're about to use these things in order to identify them in a graph. For now, I'd like you to quickly go through, pause the video, take a look at these guys, look at the degrees, see if you could list the leading coefficients. Go ahead and pause. Okay, I hope you paused. I'm going to go ahead and list the leading coefficient. This leading coefficient must be a 5. This next leading coefficient must be a 1. The next leading coefficient is a 4. The next leading coefficient is a 4. The next one is a 2. And the next one is a -1. Now, all we really care about is the leading coefficient positive or negative. We'll see why in just a minute. So I'd like you to be able to look at things like this and identify what the degree is and identify what the leading coefficient is. If you can, Next, I'm going to show you what the graph of a polynomial looks like, and we'll see how to match up the graph with these guys based on your knowledge of degree and leading coefficient. Oh, one very important thing that I forgot before we leave this screen is that it's really important that you know whether the degree of the polynomial is odd or even. We will consider the degree of 0 to be even, although I have to admit the graph of that is not all that interesting anyways. But the degree of 1, of course, is odd, right? 1's an odd number, and 2's an even number. And 3, of course, is odd, and 4 is even, and etc., etc. Okay, so I'm not giving you any new definitions. It's just new and a little bit weird to think of polynomials in terms of number degrees, and it's certainly weird to think of these guys as odd and even. So I will tell you right now, this guy right here is considered to be an odd degree polynomial. And this guy right here is considered to be an even degree polynomial. That's going to be important when we go to look at the graphs. All right, before I get going with more notes, you're going to want to make a little table on your paper that looks like this. Make sure you have an entire half a page free to write this out. I want you to have some space. So even degree on top, and then odd degree. The even degree covers this column. Odd degree covers this column. Positive leading coefficient covers this row. And negative leading coefficient covers this row. So when we're looking at something like this guy right here, this graph is going to represent odd degree and negative leading coefficient. This graph right here is going to represent even degree and negative leading coefficient. All right, go ahead and pause the video and sketch this out, and then we're going to add some stuff to it. Okay, hopefully you got that done nice and clean and easy, gave yourself plenty of space, half a page. Let's take a look. First of all, I want to remind you that if I have a function that looks like this, f of x equals x, something like that is, the x is really to the power of 1. And if we go back to that previous table, what we'd say is that if we have a function where we have x to the power of 1, that's called a first degree, and since 1's an odd number, it'd be an odd degree. And if you recall the graph of y equals x, and if you don't recall it, it's pretty easy to get it. You just make a table, and you should be able to see exactly what it looks like. And what it looks like is something like this. There we go. Now, when it comes to end behavior, and that's what we're discussing right now is end behavior, we don't really care about this middle part at all. Okay, we could care less about that. And honestly, we don't care about this point right here. We don't know what the y value is when x is small numbers. This arrow means that we're going to infinity and beyond. And so all we're concerned about is this guy is going up and to the right, and this guy is going down and to the left. And because this is an odd degree, and I'll also remind you that there's an implied 1 out in front, and that's a positive 1. So it's a positive leading coefficient, and it's an odd degree. Okay, so for that reason, the end behavior is going to look like this. Now, here's the thing that's really cool about this knowledge, is that any odd degree polynomial, if I had a polynomial that looked like this, y equals 7x cubed, on the ends, it's going to go up to the right and down to the left. Okay, if I have a polynomial that where there's other stuff, maybe I have something like 5 x to the 9th minus 7x squared. Okay, even though there's other stuff, because it's an odd degree polynomial and because it's a positive leading coefficient, the ends are gonna look like this. We don't know what the middle will look like, but the ends will look like this. Again, I told you before, the reason we want to know this is it'll help when we're trying to graph something like this. And it'll also help if we see a graph to identify what type of graph it is. We'll be able to match it up with a function possibly. All right, let's take a look. I wanted to take a little time to explain the overall concept, but now let's get to the other graphs really quickly. An even degree polynomial might be something like this. Let's say we have something like 1 x squared. You might recall that the graph of this guy is a parabola, and parabolas tend to look a little something like this. They go up to the left, and they go up to the right, and they also go to the right, and they go up to the left, and they go up and to the left, up and to the right, up and to the left. Quadratics, even degree polynomials do that. And especially when they have a positive leading coefficient. Okay, this is how they look. Now again, we don't know what all even degree polynomials look like in the middle, but if you go far, if your x values get large enough, this guy is going to be going up. The f of x or the y values will go up, and if this x value gets negative enough, then these y values will go up. Okay, so this is what the end behavior of a graph looks like if it has even degree and positive leading coefficient. And graphs like y equals 1x squared have even degree and positive leading coefficient. So again, if I have a function that looks like y equals 3, x to the, let's say 8th. I don't know exactly what that guy's going to look like, but I can tell you on the right side it's going up, and on the left side it's going up at some point. And it doesn't even matter if I have something like this as well. Still, the ends are going to go up on the right and the left. All right, let's look at a couple more. So let's go back to odd degree. You might recall that if we have a negative leading coefficient or a negative slope, let's do something like this, then we would say, well, that's going to be like a negative sloping line. And again, we don't care what happens in the middle. We're discussing end behavior. If we have an odd degree, remember, power of 1, and a negative leading coefficient, it's going to go down on the right and it's going to go up on the left at some point. In the middle, we have right now we're not even discussing what happens in the middle. And if we have an even degree and a negative leading coefficient, what we do is this. Let's say something like negative x squared. So again, even degree, negative leading coefficient, we expect something like this. Again, we have no idea what's going on in the middle. Who knows what the graph looks like here? But if we have even degree and negative leading coefficient, we know that the graph will go down as we go to the right, and it'll go down as we go to the left. All right, this is the whole idea behind end behavior of polynomials. Now you know what you can tell whether an equation has an even or odd degree. You can tell whether an equation has a positive or negative leading coefficient. And these 4 graphs are all you need to know to identify any polynomial, what the degree is and whether the leading coefficient is positive or negative. This is good for every polynomial because every polynomial is either going to have an odd or an even degree, and it's either going to have a positive or a negative leading coefficient. These are all the possibilities. Kind of cool, huh? Okay, if you're getting everything so far, then I have to apologize to you in advance for what I'm about to explain. This is sort of a weird part of end behavior of polynomials. It's trying to describe it in terms of math symbols. So if you can take a moment, pause the video, sketch this, get caught up to me, then we're going to go ahead and add some stuff. Okay, so here we go. One thing I want to point out that maybe no one has said to you before is that when we have x, the x-axis, and it says it's going this way, there's an arrow that's going this way. A way to describe this is that as we go in this direction, x is going to positive infinity. Okay. And then over here, as we go in this other direction, let me go ahead and put an arrow on over here. As x becomes very negative, then we have something else that happens over this way. The only thing that's, again, is kind of strange is that the way we describe this is we still use the arrow going to the right, except now we say negative infinity. Now this does not mean that x is going that way. What we're saying is as x, let me go ahead and do this with some blue, as x goes this way, one way to say it is x is going to negative infinity. Okay, this says x is going to positive infinity. All right, now we can say the same things about y, but when we say them about y, we treat y as f of x. So if we're talking about going upward, what we say is that f of x is going to positive infinity. Okay. In other words, these y values are positive as we go up. Okay. And as we go down, we say that f of x is going to negative infinity. All right. So here's a bunch of weirdness. So one thing that I'd like to do is I'd like to take a little time right now and I'll describe for you this parabola in terms of these red things here. Okay. What happens is for every polynomial graph, we'll have two ways to describe it. See, because this one, as we go to the right, it goes up, and as we go to the left, it goes up. So we'll need two things to say about this. The one thing that we'll say is this, is that f of x goes to positive infinity as x goes to something. So in other words, as x goes to the right, f of x goes to positive infinity. So we would say as x goes to positive infinity, or I'm sorry, f of x goes to positive infinity as x goes to positive infinity. The other thing we have to do is describe this other end of the behavior. And the way we do that is we again say f of x goes to, except, oh, in this case, we're also going to positive infinity. So f of x goes to positive infinity, again, because we're going up. And this time we say as x goes to, and in this case, it's as x goes to negative infinity. So as x goes this way, our function goes up is what we're trying to say. So this will be negative infinity. So with these two statements, we have described in a really funky way what the graph shows us in a really simple way. Now, we could do this for all four of the graphs that I just showed you on the last last slide, but I'm not going to. I just wanted to give you a taste of how these positive infinities and negative infinities and x's and f of x's work. By the way, the book explains this. There's a table that has all this stuff written out for you as well. All right, that's it. That's Behavior of Polynomials.